Differentiation. Uses of derivative. Derivative dy by dx gives the rate of change of y with respect of x. Here are some uses in business and economics. Marginal concepts. Total revenue is equal to number of units sold into price per unit, where x is equal to number of units sold, p is equal to price per unit, r is equal to total revenue. Thus, r is equal to x into p. Average revenue AR is equal to total revenue divided by number of units sold, which is equal to x into p divided by x, where x and x gets cancelled and the answer is p, the price per unit. Marginal revenue MR is equal to derivative of r divided by derivative of x. Here when r is taken as y, derivative of y divided by derivative of x. Total cost C is equal to total fixed cost TFC plus total variable cost TVC. Thus, average cost AC is equal to total cost divided by number of units. That is, total cost is equal to TFC plus TVC and number of units is divided by X. Thus, TFC divided by X plus TVC divided by X. Average fixed cost AFC plus average variable cost ABC. Marginal cost MC is equal to derivative of C divided by derivative of X. When C is taken as Y, it is equal to derivative of Y divided by derivative of X. Let us see an example. The demand curve of a monopolist is given by X is equal to 100 minus 4P. The question is, find the total revenue, average revenue, marginal revenue. At what level of X the marginal revenue is equal to 0? Solution. X is equal to 100 minus 4P, 4P is equal to 100 minus X, where P is equal to 25 minus 0.25X. Total revenue R is equal to X into P, thus X into 25 minus 0.25X. Average revenue is equal to total revenue divided by number of units sold, which is equal to 25 minus 0.25X. Marginal revenue, the derivative of R divided by derivative of X is equal to 25 minus 0.5X. Second part. Derivative of R divided by derivative of X is equal to 0, which is 25 minus 0.5X is equal to 0. When we solve it, X is equal to 50. Example number 2. If C of X rupees is the total cost of manufacturing X toys and C of X is equal to 500 plus 50 by X plus X square by 10. Find the average cost and the marginal cost when X is equal to 20. Solution. Average cost C by X is equal to 500 by X plus 50 by X square plus X by 10. Marginal cost when X is equal to 20 is equal to, we are substituting X is equal to 20. Thus, 500 by 20 plus 50 by 20 square plus 20 by 10. When we solve it, the answer is rupees 27.13. Marginal cost, that is dC by dx is equal to minus 50 by x square plus x by 5. When x is equal to 20, we are substituting x is equal to 20, that is minus 50 by 20 square plus 20 by 5, which is equal to 3.87 rupees. Elasticities. Price elasticity of demand is the ratio of the relative proportionate change in demand of X to the relative proportionate change in P. That is minus P of X, that is delta X by delta P. Therefore, price elasticity of demand at a particular price P is also called point elasticity of demand or simply elasticity of demand. For ordinary commodities, P by D by X of D by P is negative. To keep elasticity of demand positive, minus sign has been introduced. Sometimes price may be quoted as a function of quantity X, that is P is equal to function of X. In those cases, elasticity of demand is calculated as elasticity of demand is equal to minus P by X into 1 by derivative of P divided by derivative of X. Interpretation of elasticity of demand: when elasticity is less than 1, it is inelastic. When it is equal to 1, it is unitary elastic. When it is greater than 1, it is elastic.
Elasticity of supply is defined as elasticity of supply is equal to P by X into derivative of X divided by derivative of P, where X is the supply and P is the price. It is generally positive. Third question. The relation between marginal revenue MR, average revenue AR and elasticity of demand. Consider total revenue R is equal to X into P. Differentiating both the sides. Derivative of R divided by derivative of X is equal to P into 1 plus X into derivative of P divided by derivative of X, which is equal to P into 1 plus X by P into derivative of P by derivative of X, which is equal to P into 1 minus 1 divided by minus P by X into derivative of X divided by derivative of P. That is, marginal revenue is equal to average revenue into 1 minus 1 divided by elasticity of demand, which is equal to average revenue into elasticity of demand minus 1 divided by elasticity of demand, which is equal to average revenue is equal to marginal revenue into elasticity of demand divided by elasticity of demand minus 1. First question. Equation 1 can be written as marginal revenue divided by average revenue, which is equal to 1 minus 1 by elasticity of demand. 1 by elasticity of demand is equal to 1 minus marginal revenue minus marginal revenue divided by average revenue, which is equal to average revenue minus marginal revenue divided by average revenue. Elasticity of demand is equal to average revenue divided by average revenue minus marginal revenue. Among average revenue, marginal revenue and elasticity of demand, one of them can be found out from the another two using the relation of 2, 3 and 4. Third question. If the demand law is X is equal to 20 divided by P plus 1, find the elasticity of demand at the point when P is equal to 3. Solution. Derivative of X divided by derivative of P is equal to minus 20 by P plus 1 the whole square. Elasticity of demand, that is, elasticity of demand is equal to minus P by X of derivative of X divided by derivative of P, which is equal to minus P by 20 divided by P plus 1 into minus 20 divided by P plus 1 the whole square, which is equal to P by P plus 1. At P is equal to 3, elasticity of demand is equal to 3 by 3 plus 1, which is equal to 0.75. Example 4. If the demand function is P, which is equal to 4 minus 5x, for what value of x will elasticity of demand be unitary? Solution. From P is equal to 4 minus 5x, dP by dx is equal to minus 5. Elasticity of demand is equal to minus P by Px into 1 by derivative of P divided by derivative of x, which is equal to minus 4 minus 5x divided by x into 1 by minus 5. The value of x such as 4 minus 5x divided by 5x minus 1, that is 4 minus 5x is equal to 5x or x is equal to 0.4. Example 5. Find the elasticity of supply from the supply function P is equal to minus 2 plus 5x. Solution. Derivative of P divided by derivative of x is equal to 5. Elasticity of supply is equal to P by x into 1 by derivative of P divided by derivative of x. Elasticity of supply is equal to minus 2 plus 5x divided by x into 1 by 5, which is equal to 5x minus 2 divided by 5x. Example 6. If the marginal revenue is rupees 25 and the elasticity of demand with respect to price is 2, then the average revenue is equal to dash. Solution. By substituting the given values, average revenue is equal to marginal revenue into elasticity of demand divided by elasticity of demand minus 1, whereas 25 into 2 divided by 2 minus 1, which is equal to 50. Increasing and decreasing function. A function f of x is said to be increasing at x is equal to a if an neighborhood of the point a, f of a, the graph of the function raises as it moves from the left to right. The first derivative measures the rate of change, hence a positive first derivative at x is equal to a indicates that the function is necessary, which shows in this diagram. Increasing function at x is equal to a, f of a which is greater than c. A function f of x is said to be decreasing at x is equal to a if in the neighborhood of the point a, f of a, the graph of the function falls and moves from the left to right. A negative first derivative at x is equal to a indicates that the function is decreasing, which shows in this diagram. Decreasing function at x is equal to a, f of a which is lesser than 0.
F dash x is greater than 0 indicates that fx is an increasing function, and f dash x less than 0 indicates that f of x is a decreasing function. Example 7. The total cost function y for x units is given by y is equal to 3x into x plus 7 divided by x plus 5 plus 5. Show that the marginal cost decreases continuously as the output increases. This question can be solved by mc dy by dx is equal to x plus 5 into 3x plus 3 into x plus 7, the whole minus 3x into x plus 7 divided by x plus 5 the whole power is equal to 3x square plus 15x plus 3x square plus 15x plus 21x plus 105 minus 3x square minus 21x divided by x plus 5 the whole square is equal to 3 into x square plus 10x plus 25 plus 30 divided by x plus 5 the whole square. So d by dx of mc is equal to 30 into minus 2 divided by x plus 5 the whole cube into 1, which is equal to minus 60 divided by x plus 5 the whole cube, which is less than 0. Hence marginal cost decreases as the output increases. Maxima and minima. Consider the following graph of the function y is equal to f of x. At a, the function has attained maxima. The value of y at a is greater than its value in the neighborhood of a. In other words, y is a maximum at a, y is a maximum at the point c also. At b, the function has attained minima. The value of y b is less than its value in the neighborhood of b. In order it ends, y is a minimum at b, y is a minimum at the point d also. This is the graph that represents the following. dy by dx gives the rate of change of y with respect to x. It is positive on the left side of a, it is negative on the right side of b. It is 0 at a. Similarly, dy by dx changes from negative sign to positive sign around b. It is 0 at b. Hence, the first order condition for y to be either maximum or minimum is dy by dx is equal to 0. The next aspect considered concerns dy by dx. dy by dx changes sign from positive to negative around the maxima of y. Hence, dy by dx increases mathematically. d square y by dx square is less than 0 at value of y around the minimum of y. dy by dx changes sign from negative to positive. This is dy by dx increases. Mathematically, d square y by dx square is more than 0 at the minimum value of y. Hence the second order conditions. d square y by dx square is less than 0 for y being a maximum. d square y by dx square is more than 0 for y being a minimum. To summarize the conditions for an extremum, dy by dx is equal to 0 and d square y by dx square less than 0 for a maximum. That is, f dash a is equal to 0 and f double dash a is less than 0 for f of x being a maximum at x is equal to a. dy by dx is equal to 0 and d square y by dx square more than 0 for a minimum. That is, f dash a is equal to 0 and f double dash a more than 0 for f of x being a minimum at x is equal to a. Note, f of x is neither a maximum nor a minimum at x is equal to a if f double dash a is equal to 0. Steps for finding an optimum value of function y is equal to f of x. First dy by dx, next find d square y by dx square, then take dy by dx is equal to 0 and solve for x. Examine the nature of d square y by dx square at each critical value of x obtained in step 3. Conclude that y is maximum when d square y by dx square is less than 0 and y is a minimum when d square y by dx square is more than 0. 5. Find the maximum and the minimum values of y if required. They are found by substituting the critical values of x obtained in step 3 in y is equal to f of x.
Example 8. Find for what values of x the following expression is maximum and minimum respectively. 2x cube minus 21x square plus 36x minus 20. Find also the maximum and the minimum values. First of all, we are taking that y is equal to 2x cube minus 21x square plus 36x minus 20. Next, we are finding dy by dx is equal to then x square 6x square minus 42x plus 36, then expression to d square by dx square is equal to 12x minus 42, then expression 3 dy by dx is equal to 0, x square 6x square minus 42x plus 36 is equal to 0. Finding both sides by 6, x square minus 7x plus 6 is equal to 0. Then we are finding the linear equation ax square plus bx plus c is equal to 0. Then x is equal to minus b plus or minus whole root b square minus 4ac divided by 2a. There is linear equation formula as a is equal to 1, b is equal to minus 7 and c is equal to 6, x is equal to, then we are substituting the values of a, b and c in the linear equation formula. Then as we find that the answer is 7 plus 5 divided by 2 or 7 minus 5 divided by 2, then there will be one 6 or 1. Next, when x is equal to 6, we are finding that when we are using the plus, when x is equal to 6, d square y divided by dx square is equal to 12 into 6 minus 42 is equal to 30. It is greater than 0. Y is minimum when x is equal to 0. 6. The minimum value of y is equal to 2 into 2 of 6 cube minus 21 of 6 square plus 36 of 6 minus 20 is equal to minus 128. When x is equal to 1, d square y divided by dx square is equal to 12 into 1 minus 42 and minus 30. It is greater than or it is less than 0. Now y is minimum when x is equal to 1. Then the minimum value of y is equal to 2 of 1 cube minus 21 of 1 square plus 36 of 1 minus 20. Note, profit is equal to revenue minus cost is equal to x dot p minus cost. Revenue is equal to x dot p, so we are considering that revenue for x dot p. Okay. Next problem. Example 9. A firm sells a product at 3 per unit. The total cost of the firm for producing X unit is given by C is equal to 20 plus 0.6x plus 0.01 x square. How many units should be made to achieve maximum profit? Verify that the condition for a maximum is satisfied. First of all, we are taking that y is equal to 3x minus 20 plus x plus, we are taking that equation, then find out dy by dx is equal to then 3 minus 0.6 minus 0.02 x. Then next step we are finding that d square y divided by dx square is equal to minus 0.02. Step 3, dy by dx is equal to 0, then 2.4 minus 0.02x is equal to 0. X is equal to 2.4 divided by 0.02 is equal to 120. Then step 4, 120 units are to be made to achieve maximum profit. We have found out that 120 is maximum unit. 120 units to be made for achieving the maximum profit, as d square y divided by dx square is less than 0. The condition for the maximum is satisfied. Note, the maximum profit is required is equal to 124. We are finding that 124 is maximum profit is required. Okay, let's solve this problem over. Next problem, example 10. A steel plant produces X tons of steel per week at a total cost of rupees x cube divided by 3 minus 5x square plus 99x plus 35. Find the output level at which the marginal cost attains its minimum. They have given the equation that we are writing that c is equal to x cube divided by 3 minus 5x square plus 99x plus 35. That they have been given that equation in the question. Next, marginal cost. Then dc divided by dx is equal to x square minus 10x plus 99. Then y is equal to x square minus 10x plus 99. As x is required such that y is a minimum, we find dy by dx is equal to 2x minus 10. Then next step, d square divided by dx square we are finding that 2. Then we are finding dy by dx is equal to 2x minus 10 is equal to 0 or x is equal to 5. Then next step, as d square y divided by dx square is greater than 0, it is concluded that at the output level x is equal to 5. The marginal cost attains its minimum. Example 11. Next problem. The total cost function of a firm is given c is equal to 0.04 q cube minus 0.9 q square plus 10q plus 10. Find average cost and marginal cost and value of q at which average variable cost is minimum. They have given that AC is equal to x divided by x is equal to 0.04x square minus 0.9x plus 10 divided by x. Then q is equal to x. Marginal cost, dc divided by dx is equal to 0.12x square minus 1.8x plus 10. Next, we are finding average variable cost. Total variable cost divided by x is equal to average variable cost. So we are finding that 0.04x square minus 0.9x plus 10 is equal to y. Then they are finding as dy by dx is equal to 0.08x minus 0.9. Next step 2, we are finding d square y divided by dx square is equal to 0.08. Hence it is greater than 0, y is minimum. Next, third step, we are finding dy by dx is equal to 0.08x minus 0.9 is equal to 0, or x is equal to 0.9 divided by 0.08 is equal to 11.25. That is q is equal to, we have found out that 11.2x. Average variable cost is minimum. This problem also over.